Okay, so now we're going to go through the chemistry assignment for ammonia. So let's start on this. Okay, so first question. The graph below shows how temperature and pressure affect how much ammonia is produced in the Haber process. So whenever you have a graph, always try to find out what the exact y and x-axis are to interpret it. So in this case here, my y-axis is the amount of ammonia produced in terms of percentage. So this is sort of like the percentage yield. And obviously, because it's a percentage, maximum is 100%. On the x-axis, I got temperature. So this is about temperature as well. And each of these lines that you're seeing, each of the graph lines you're seeing represents a different pressure. Okay? So let's start on the question. So describe how the amount of ammonia changes as the temperature increases. So realize as the temperature increases, the ammonia percentage drops to a low percentage. So what you realize, in this case here, they're just asking you to describe, there's no need to code data. So all you need to just do is as the temperature increases, the amount of ammonia produced decreases. Okay? So I'm just using my y-axis and my x-axis and trying to determine the relationship in terms of increase and decrease. Now this is the simple type of answering. There's a certain segment where they will ask you for data. So the next question they're going to ask for about data, and we can take a look at it. Okay, let's start. So you can see here, using information from the graph above, describe the effect of pressure on the amount of ammonia. So I know that, actually if you look at it, I know as the pressure increase, the yield actually gets higher. Now, but you cannot just look at the graph and say like, okay, you know, it will increase. The general idea is actually it's best if you can lock down a certain temperature and then from there compare the value of the yield. So if you look at this here, okay, if you look at this here, the general idea start, of course, is how the thing works lah. So I can say that as the pressure increases, the amount of ammonia produced increase. That's the effect. But next part, I need to use the information. So what you can see here is actually they locked at 300 degrees Celsius. So what they did is 300 degrees Celsius, I draw a line like this. Then I choose two pressure. So in this case, they chose 25 and 400. So at 25, at 400, so this is 56, this is 10. So how they go about is, for example, I will normally write at 300 degrees at the start, okay, when the pressure increases from 25 to 400 atm, so you need to quote the values. The amount of ammonia produced increases from 10% to 56%. So you realize it tallies with the value here. Now, must I use 300 degrees? Answer is no lah. I can use 200 as well. I can use 100 as well. But as you use 200 or 100, the value of the amount of ammonia produced, the percentage, will actually change accordingly as well lah. So just take note. Okay. Next, state the amount of ammonia produced at 150 degrees Celsius and at 25 atm. So I need to look out for 150 degrees Celsius. So 150 degrees Celsius is over here. So I'm going to draw a dotted line up. And at 25 atm. So 25 atm is this line over here. So this is my 25 atm. So what I know is that my percentage yield is 40%. Okay? So a lot of data interpretation, graphical skills kind of understanding from there. Okay, next one. An ammonia production plant decides to use condition of 400 atm to produce ammonia. So actually it's a good thing to use 400 atm because you realize 400 atm, the pressure is high, my yield is definitely higher lah. As you can see, based on our description, pressure increase, the amount of ammonia produced also increase as well. Okay, so that's good. But what is the one issue that the production plant will face? So this is a bit more in terms of your real life situation. If I want to have high pressure, okay, when I have high pressure, there's a few situations I'll face. Equipment got to be more expensive. I need to spend more money to also maintain that high pressure itself. So this will result in an increase in cost because I need stronger equipment to withstand the pressure of the reaction. So there's a higher cost involved, and it's not just about having that stronger equipment. Actually, maintenance itself also will cost a bit more money as well, okay? Because it is a better equipment. So this is realize that okay, so far not too bad. Reading the graph, trying to understand, situation, and a bit of real life application as well. Okay, next one. The next question. Ammonia is manufactured by the Haber process. So you can see here, and take note, ammonia is actually a reversible process or reversible reaction. That's why I use the double-headed arrow. So the conditions in this Haber process is 250 atmosphere, which is 200 atm, 450 degrees Celsius, and finely divided iron catalyst. So state how the raw materials of nitrogen and hydrogen are obtained for the Haber process. This one you need to know. So take note, this is commonly asked either in MCQ or your structured. So know where they are from. So for nitrogen, it is fractional distillation of liquid air. So just take note, liquid air is important and it's fractional distillation. So actually there are 3 points here. Most students, when they write very quickly, they always forget the liquid air, the liquid in the liquid air. So just take note. Hydrogen is actually from the cracking of crude oil. Okay, cracking of crude oil. So this one, you're going to learn a little bit more when you reach the chapter of organic chemistry. So you're going to learn a bit more about this. For fractional distillation of liquid air, when you reach the chapter of maintaining air quality, okay, you're going to learn more about this as well. Okay, so for now, just know that to obtain nitrogen, use fractional distillation of liquid air. Because nitrogen actually is about 78% of air. I can get a lot of nitrogen from air itself. Okay, next. Newer catalyst has been discovered for this process. Using this catalyst, the operating temperature is lowered from 450 to 400. Okay, so 50 degrees lower is actually a good thing. So what's the advantage and disadvantage of using a lower temperature? So if I use a lower temperature, you know that actually lower temperature obviously cost will be lower lah, because I don't heat it up so much. But you also know temperature affects actually your speed of reaction. Okay, speed of reaction. So what's the advantage and disadvantage? You can see here. Lower temperature actually enables a higher percentage yield of ammonia. Okay, in this case, it's more about the reaction, but actually cost can also play a part as well. It's actually a lower cost. Okay, the disadvantage is that actually lower temperature causes the rate of reaction to decrease. So lower temperature, higher percentage yield of ammonia. Lower temperature, problem is the rate of reaction decrease. So it takes a longer time to get the same amount of products. Okay, so just take note, temperature affects yield. The lower, the higher the... So low temp actually got two effects. It increases the yield, which is good, but then it decreases the speed of reaction, which is bad. Okay? Now obviously the reverse will hold true. So if I got high temperature, what's going to happen is it's going to decrease the yield, which is bad. But the good thing is I'm going to increase the speed of reaction. Okay, so see this as a temperature as a double-edged sword for this Haber process itself. Okay, next. After passing over the catalyst, the mixture contains 15% of ammonia. When the mixture is cooled, the ammonia liquefies and is separated from the unreacted nitrogen and hydrogen. The unreacted gases are recycled. Now, generally, recycle is because if unreacted, you let it go out, it's a waste. So actually, generally recycle because you don't want to waste the gas lah. Okay, so you recycle. Obviously, first is to conserve our natural resources so you don't waste, and then this will actually help you to reduce costs incurred in the manufacturing. And if I can recycle the gas, obviously for the same amount of reactants, I can increase the amount of products formed. So if I imagine I put in 100 hydrogen and nitrogen, come out only like 15 ammonia. But if I can recycle the rest, I can actually get more ammonia out from the amount of hydrogen and nitrogen that I put in. So that's the idea of increasing yield as well. Okay? So quite a few factors that you can write in terms of this one. Next one. Only ammonia gas liquefies when the mixture is cooled. That means I got nitrogen, I got hydrogen, I got ammonia. Then when the temperature drops, okay, only this fella liquefies, becomes a liquid, right? So why is it so? Generally, those that can become your liquid faster actually has a higher melting and boiling point, right? But in this case, because it's about liquefying, so it's about boiling point. So in general, ammonia has a higher boiling point than nitrogen and hydrogen gases. Okay, that's why they liquefy first. Next, fertilizers are added to soil to ensure that plants acquire the essential elements, nitrogen, potassium, and phosphorus for effective growth. So for effective growth, you need three things, phosphorus, potassium, and nitrogen. Okay, urea, CONH22 is one of the fertilizers manufactured from ammonia. So you can actually make urea from ammonia. It can be produced by heating ammonia with carbon dioxide. So ammonia heat with carbon dioxide, you can produce urea, and the other product is water. So you realize this is the reactant, this is the reactant. Your product is urea and water. So write a balanced chemical equation for the manufacture of urea. So this is going to be ammonia plus carbon dioxide gives me urea plus water. So then you realize that the CO2, one of the O comes to the water, the other O goes to the CO in the urea. And I got NH2 over here, down here I got NH3. So obviously based on nitrogen, I need to put a 2 over here. Then where did the other 2H go? It actually goes to the water over on this side. So you realize by putting 2 at the ammonia side, you actually balance the whole chemical equation. Most students, when they do this question, they are stuck because they wrote NH3 plus CO2 gives me CO bracket NH2, 2, and then like, cannot do leh. How to do? They forgot to read this water part, so take note, read your question carefully. Especially this kind of that has context. Okay, always read your context carefully. Next, explain why urea on its own, okay, sorry, why did I circle my bad. On its own, okay, it may not be very effective for promoting crop growth. So did we talk anything about crop growth? Yes, right? Do you realize that for plants to grow, for effective growth, I need three things: nitrogen, potassium, and phosphorus. What does urea have? You realize urea only has nitrogen. So why is it not very effective? Because it only has one of the essential element. It's still short of the other two. So therefore, urea only contains nitrogen, only nitrogen. It does not contain other essential elements. Please quote it: potassium and phosphorus, which are important for crop growth as well. Okay? So that's for this question 2. So just take note. So say, how is this linked to my chemistry? This is about reading. The elements are there. This is about referring back to context. So this is about making sure that you read your data carefully. Don't just leave it as it is. Read the question carefully. Next, 3A. Explain the following observations. So dry litmus paper does not change color when added to dry ammonia gas. So you realize the keyword is dry lah. Why is dry litmus paper not able to change color when you got dry ammonia gas? Now I know ammonia is an alkaline gas, but when will the alkaline gas take effect is when there's water. Why? It's because what happens is that when the ammonia gas reacts with the water, or I should say interacts with the water, what you are going to get is ammonium cation. Okay, nothing too exciting. But the thing that caused the litmus paper to change color is because you got hydroxide ion produced, which you know that is the cause of it being alkaline. So since no water is present, it cannot dissolve and cannot dissociate to form hydroxide ions. So dissolving, dissociating, keyword. Okay, and obviously hydroxide ions. Okay, so take note of these little things here. Next, part 2. Ammonia gas cannot be collected over water, but can be collected by downward displacement of air. Now, downward displacement of air, okay, this is actually your upward delivery. So this is a very old way of phrasing already. Now we don't really use the term downward displacement, upward displacement of air. We just use the term upward delivery or downward delivery. Okay, so why cannot be collected over water? Is because it's very soluble in water. Ammonia, dissolves in water very easily. That's why it cannot be collected over water. Why it can do downward displacement of air, or we say upward delivery? Because there's a lower density than air. That's why it will rise up. Now, many students like to put lower MR or higher MR. Now, this whole lower and higher MR thing just affects rate of diffusion, but it doesn't affect whether it's rise or sink. The rising and sinking affects the upward or downward delivery, which then is all about density. So take note, upward delivery, okay, means that gas must be less dense compared to air. Okay? Then, of course, if you are doing a downward delivery, the gas must be denser than air. Okay, where do you pick up all this? So take note, this is back in your chapter 1. So those of you can't really recall this part, please go and revise back my chapter 1. Okay, next one. Nitrum fertilizer is manufactured by reacting nitric acid with aqueous ammonia. Okay, according to the equation. So you can see here, you realize, oh, this one looks so familiar. Actually, this is your ammonium nitrate. So ammonium nitrate is actually part of your nitrum fertilizer is actually consisting of ammonium nitrate. Draw a dot and cross diagram to represent the bonding in ammonia. Now, this is ammonia, not nitrum fertilizer, so I just focus on NH3. They even give you the formula here already. So take note, this is the drawing. Okay, sorry, not so draw letter. It's supposed to be N, circle, bonded to 3 hydrogen. Okay, let me do the whole thing properly for you. So I know that there's a single N, so that must be in the middle. All the hydrogens will surround it. Okay? Now, nitrogen, hydrogen will only form a single bond, and you will know that every single thing will actually bond to the middle. So this is my structural formula that I'm supposed to draw. Then, of course, I need to convert this into my dot and cross. So now I'm going to do my dot and cross. So how to do my dot and cross diagram is translating this to my dot and cross. So nitrogen in the middle with a big circle. As long as there's a bond, there must be an overlapping circle. H, H, H. A single bond represents a cross and a dot. So cross dot here, cross dot, cross dot. Now, once you are done with this, it's not the end yet. Because why? You need to double check. So hydrogen, I have 1 electron in the outer shell. So outer shell, I got 1 electron. Bonding, you realize you use 1 electron. So therefore 0 left over. Okay, or 0 unbonded. Now for nitrogen, you realize that it has 5 electrons in the outer shell. 3 electrons used for bonding. So I'm left with 2 unbonded electrons. So I need to draw 2 more electrons that's not bonded. And this is my dot and cross. Okay, so generally you also have that circle over here that most of you are very familiar with. Okay? B part 2. Farmers should not add nitrum fertilizers immediately to the soil after they are limed with calcium hydroxide. Explain why. So calcium hydroxide is an alkali, right? Actually, calcium hydroxide, 2 things only. One is it's a lime water, so it reacts with carbon dioxide. The other thing is you think of it as alkali. So alkali can react with either my acid, or alkali can react with my ammonium salt. So how is nitrum fertilizer carbon dioxide? Obviously not. Is nitrum fertilizer an acid? Obviously not. But what I know is nitrum fertilizer is actually an ammonium salt. So why should I not add my ammonium salt to my calcium hydroxide? So I add ammonium nitrate to my soil, okay, so that the nitrogen can go to the plant. Okay, so that nitrogen can go to the plant. That's the key idea, right? But what happens is that when I got calcium hydroxide, my ammonium nitrate will actually react with my calcium hydroxide. And when this reaction occurs, my NH3 will be produced. So that means I got ammonia gas produced, and actually it means that if it's a gas, the nitrogen will actually escape into the surrounding. instead of going to the plant. So that becomes a problem because I want all my nitrogen to go to the plant, but because of the reaction between calcium hydroxide and the ammonium salt, it doesn't go to the plant. Okay, so key idea, first thing, talk about the reaction. So the ammonium nitrate and the nitrogen fertilizer will react with lime to produce ammonia gas. Okay, that's the first step. But what's the problem with this? Is because ammonia will escape from the soil. Once it's escaped, there's a loss of nitrogen, which is an essential element for the plant to grow well. Okay, so this is the answer. So take note, one part is the reaction, and then the other one is like the impact or the consequence. Okay, in terms of the context of the question about plant growth. Can? Okay, so that's all for ammonia. Okay.